Hi guys, here we go. Almost all done. This exercise is to give you some math help with the gas laws because you definitely will have to do them if you take chemistry again. So here we go. This worksheet has 10 problems covering 4 gas laws. 5 gas laws. So here we go. A couple things to remember. You have to remember about STP, standard temperature and pressure. Remember 1 mole of any gas at STP occupies 22.4 liters of volume. Remember standard temperature is 0 degrees Celsius. Remember standard pressure is 1 atmosphere, but also remember that 1 atmosphere of pressure is equal to 14.7 pounds per square inch. It's equal to 760 millimeters of mercury. It's equal to 760 torr. It's another term. And the main one that we use, but you have to be able to do use them all, is 101.325 kilopascals. So just wanted to remind you about that. Also remind you that we've got our friend Boyle, we've got our friend Charles, we've got our friend Gay-Lussac, we've got the combined gas law. There's also one with Avogadro. There's also Dalton's law of partial pressure, but that's not on here. There's also the ideal gas law. So I'm going to do one of each type, and then you're going to have to do the other ones. Hopefully this will be clear. So whenever you're reading these are word problems. Make sure you find all the numbers, and sometimes words represent numbers, and see what they're asking for. So this gives us a volume and a pressure. And this asks what volume if there's a new pressure. So we're being given a volume and a pressure, and we're going to have to solve for the new volume. So volume number 2. So pressure and volume. The first volume is 500 milliliters. The first pressure is 800 millimeters of mercury. The new pressure is 200 millimeters of mercury. And so hopefully you remember that pressure and volume are related in Boyle's law. And the working version of that is P1V1 equals P2V2. So when I solve problems, I write the equation down, and then I find the variable that I need to solve for, and I solve the equation for that variable before I start plugging in numbers, because all these weird numbers and measurements get kind of confusing, and so it's better, I find, to do this. So if I wanted to isolate the variable V2 is equal P1V1 over P2, and the pressure units will cancel. We'll be left with the volume unit. So I know I have it set up right. So here we go. P1, 800 millimeters of mercury. V1, 500 milliliters, all over 200 millimeters of mercury. These are relatively easy problems to solve, and you may be able to mentally see, or hopefully you know, that this is an inverse relationship, right? If pressure goes up, volume has to go down. So the pressure went down, that means the volume should go up. So that's another thing you can do to kind of check. You can cancel things out. Mentally, you can push it through your calculator. I always like to cancel out the units to make sure I've got the right unit for the term I'm trying to find, and I do. And so pretty easily, I hope you can see that's 2,000. So you'll need to do number 2. I'm going to skip to number 3. This has a volume listed and a temperature, and that temperature is minus 33 degrees Celsius. Now we have to be really careful. Remember that you change temperature to Kelvin. That's the only way these work out for gas laws. So you're going to have to add 273 to this temperature Celsius to get Kelvin. Okay, so we'll do that in a minute. So the first volume is 4 liters. The temperature is increased to 27, so the new temperature is a positive 27, and we're trying to find the new volume again. Okay, so this time we got volume and temperature, and hopefully you know that that's Charles's law. And that is a direct relationship. Increased temperature, increased volume, decreased temperature, decreased volume. So this is going to be in a fraction form. V1 over T1 equals V2 over T2. Before I forget, I like to do the temperature conversions. Otherwise, I tend to put the wrong numbers in. So minus 33 degrees C plus 273 should give us 240 Kelvin. So, and then a positive 27 degrees C plus 273 should give us 300 Kelvin. Okay, and that's T2. So this way I make sure that I don't use the wrong number. So again, set up the, write the formula. And circle the variable that you need to solve for, and then do what you have to. So you know if something's in the denominator, you have to multiply both sides by that to get it out of the denominator and to get V2 isolated. So the final volume is going to be equal to the initial volume divided by the initial temperature times the final temperature. So again, temperature units on top, temperature units on bottom, they'll cancel, we're good to go. So V2 is equal to 4 liters, the starting volume, times the starting temperature, which is 240 Kelvin, all divided by the final temperature, which is 300 Kelvin. Oh, I'm so sorry, I messed myself up, didn't I? So this is in the wrong place. And there we go. Hopefully I didn't confuse you too much. So this should be the 240 down here. Okay, so again, Kelvin cancels. 4 times 300 is 1200 divided by 240 gives us 5.0 liters. All right, so question, problem number 4 has that already in Kelvin, so that makes it easier for you. All right, number 5 has a question of what temperature, so I know the final temperature is going to be what I'm solving for. The starting temperature is at 100 Kelvin, so that's nice, already there, and pressure is 5 atmospheres to start and 8 atmospheres at the end. So you probably recognize that pressure and temperature are directly related, and those are related in Gay-Lussac's law, which is P1 over T1 equals P2 over T2. Again, changing temperature is going to change the pressure because it makes them move faster. Temperature's already in Kelvin for us, so that's nice. We don't have to do anything except write the equation. Solve for the variable. So this is, I don't know about you guys in algebra, but this is always tricky when there's something in the denominator and it needs to be on top. You may have learned cross multiplication as a way to solve these kind of things. I am going to walk you through it. And they cancel, okay? And then to get rid of P1 over T1, I have to divide by P1 and multiply by T1. So I invert it. Okay. And these guys will cancel out. And so the final temperature is going to be equal to the final pressure times the initial temperature over the initial pressure. And again, I'm going to get temperature units in the numerator, so we're all set. T2 is what we're solving for. P2 was 8 atmospheres. Initial was 5 atmospheres. And the initial temperature was 100 Kelvin. So we've got 800 divided by 5, and that ends up being 160 Kelvin when you push it through your calculator. All right, gas is collected and temperature is 7 degrees. The pressure is 140, the volume is 4. Uh-oh, so we need a new volume. The initial temperature is 7 degrees C, and again, we got to change that. And the final temperature is 27 C. And I'm losing my place. There we go. Pressure 140. And new pressure 60. All right, so we're solving. Hopefully you see if we've got 3 variables, this is the combined gas law. And it's P1, V1 over T1. So it's just putting together all of the others that we've just done. And again, change temperature right away. 7 degrees plus 273 is 280. 27 plus 273 is 300. And then we can go off to town. So again, P1 V1 over T1 equals P2 V2 over T2. We're trying to solve for V2. To get rid of pressure, I have to divide by the final pressure, and I have to multiply by this, and I have to do it to both sides. So let's just make it pretty. V2 equals P1 V1 over T1 times T2 over P2. And again, I've got pressure on top and bottom, so their units will cancel, temperature, top and bottom, the units will cancel. I'm left with volume and the numerator. I'm all set to go before I try and mix myself up. So initial pressure, 140. Initial volume, 4 liters. Initial temperature, 280. Final temperature, 300. Final pressure, 60 kPa. Okay. Kelvin, cancel Kelvin. KPA, cancel KPA. I'm left with liters. And my paper needs to get liters. So there you go. All right. And then once you push that through your calculator, you should come up with 10 liters. I think I fixed it already, but this should be atmospheres of pressure. So because it tells you there's 1 atmosphere. All right, and then the last one is that I'm going to do with you is this number 9. 3.7 moles of propane, room temperature 22, kPa, and again, there's this obviously, hopefully, the ideal gas law, PV equals nRT. Remember, R is the ideal gas law constant, but it's only constant for certain units. Remember, pressure units and volume units can change. So the pressure and volume have to be accounted for. Make sure that you got the right R values. So for this one, there's actually a problem within the problem. You're going to have to solve for R. And then just write down the information you have. So for N, we got 3.7 moles. For room temperature, again, we're going to have to change this to Kelvin. Keep 154.2 kPa. And it's asking what volume, and it's going to be in liters. So that gives us some information. So again, 1 mole of any gas occupies 22.4 liters. So you have to have the right value for your pressure. So I already did this on the front page, but I'm just going to put it here. PV over NT. Pressure, 1 atmosphere pressure is 101.325 kPa. 22.4 liters. 1 mole at 0 Celsius, which is 273 Kelvin. So this is the one that's predominantly in your textbook, the 8.31 kPa liters over moles Kelvin. Lots of units, right? So that's where you start. The process now is simply to solve the equation. So the question is, what's the volume? So volume is going to be equal to the number of moles times the ideal gas law constant times the temperature over the pressure. So that's 3.7, 8.31, oops, 295, all over 154.2. And I didn't put all the values in there, bad me, but hopefully you get this as well, okay? So you probably figured out that every other one, every two are the same, so you know this is going to be the ideal gas law. I've got all the variables. You are going to have to calculate a different R value because this is using atmospheres, okay? So just know that going into it, and good luck. Let me know if you have any questions.